All right, everybody. So here is the next lesson, understanding right and left limits. All right, so use your graphing calculator to find the limit. So like before, yesterday, or earlier today, whenever you're doing this lesson, if you try to plug in, you get 0 over 0. So you can't do this. I am going to show you how to do this algebraically, but I'm asking you to do it using your calculator. So when I looked at my table, I got 6. So the answer is 6. That's what you should have gotten. All right. What is a one-sided limit? In order to decide if a function has a limit, we need to check the limit of the function from the left and from the right. So the little minus, the limit of f of x at x approaches c, notice this little minus sign there? That means from the left. So whenever you see a negative, and just think about it like on a number line, your positive numbers are on the right, your negative numbers are on the left. So a negative means from the left, and the plus means from the right. So yesterday we were looking at problems with like a hole, right? So we can look at what's happening from the left as we're going towards it, what's happening from the right as we're going towards it, okay? All right, the limit L of a function, y equals f of c as x approaches, y equals f of x, this should be an x. As x approaches, a number c exists. If and only if both one-sided limits exist at c, and both one-sided limits are equal. So the only time a function, the limit exists at a point, is if the left and right limits exist, then the limit exists. So again, let's use this example of a line with a hole in it. The limit here exists, even though the function value doesn't exist. As we're going from the left, we're reaching, say this point is 7, right? We're getting really close to 7 on the left, we're getting really close to 7 on the right. Since it's from the left and the right are both 7, the limit is 7. A time that wouldn't work is if we had a line like this and then there's a jump in it, like this. So this time the limit from the left would be, say, 7, and this one would be 9. Right? So that one is one that wouldn't work. And we're going to look at a bunch of examples. All right, so pause the video and just like kind of try to take in this graph. So it says the limit as x approaches 1 from the left. So we're going left of 1. So here's 1. If I'm left of 1, right? So I'm over here and I'm going towards it. What's that y value I'm getting really close to? I'm getting really close to 1. Okay. 2 from the right. So I'm right of 2. So I'm over here and I'm going towards 2. What's that y value I'm getting really close to? Well, just like this hole here, that's 2. That's the y value 2. The limit as x approaches -2. -2. So now it's not saying left or right. It's just -2. So at -2, what's happening? Well, from the left, this is a nice smooth curve, right? So it's just 4. And that's it. All right, so now we're going to get a little harder. So look, again, pause the video, take a look at this graph, see if you can figure these out on your own before I just give you the answer. All right, so -4 from the left. So left of -4. So here's -4, and I'm left of it. Here's my person, and I'm walking towards it. What is my y value from the left? It's just 1. What is my y value from the right? Well, if I'm right of -4, I'm on this part of the graph. So walking, walking, walking. What's the y value I'm approaching? I'm approaching -2. So that means since I'm approaching 2 different y values, what's the limit at -4? D&E does not exist. Okay. All right, how about 1? So here's 1 over here. I'll switch to green. So we have 1. So I'm to the right of 1. So I'm to the right of 1, and I'm walking towards it. What am I approaching? I'm approaching the y value 3. Remember the function value doesn't matter. It's just what am I approaching? 3. From the left, this time the guy's going up this way. Again, I'm approaching 3. So from the left and the right, it's equal. Those two were both 3, so my limit is 3. Again, it doesn't matter. The function value does not matter at this point. All right, pause the video. Try these on your own. So -2 from the right. So here's -2. I'm right of that point, and I'm going towards it. What am I getting close to? 0. -2 from the left. Again, same thing. 0, 0. So those are all nice. That one works. 1 from the right. So now we have a problem here. Where's the graph from 1 to 2? It's non-existent, so this has to be a D&E. From the left, we're going this way, so just 3. Those are not the same, so it does not exist. Because of that gap there, we can't really do this one. All right. Again, pause the video, try it on your own. All right, -1 from the left, so -1, okay, red on red isn't helpful. So I'm from the left, so I'm coming this way, it's 1. -1 from the right, so I'm right at -1, so I'm going this way. That y value is -2. So that means, does it ask the whole, oh wait, I put the wrong one. This is -2. So what's the limit at -1? It does not exist. Those are not the same. Whenever there's a jump like that in the graph, there's a big gap. What is h of -1? So what is the function value? So the closed circle is at 1, right? This is my closed circle. All right, 3 from the left. Left of 3, I get 2. Right of 3, my y value is 3. Again, those two numbers are not the same, so D and E. H of 3, where's the closed circle? The closed circle is at 2. All right, so now this one is a little tricky because we're not looking at the graph, we're looking at the just a piecewise function. So left of 1, where are we if we're left of 1? That's our top, right? Think about, we have 1, 4. So this is our x squared minus 3. This is our -7x plus 5. And this is our -4x plus 5 minus 10. So if it helps, you can write it out like that, like as the number line. So left of 1, we're going to plug in 1, and what do we get? 1 minus 3 is -2. To the right of 1, so now we're going to plug in the -1 into the -7 plus 5. So what do we get there? 1, that's -2. Which means, what's the limit? -2. Perfect. All right, now try 4. What's happening at 4? So if I plug in 4, that's like a lot of work. All right, -28 plus 5 is -23, so that's the left. All right, so we got -4 times square root of 9 minus 10, -12 minus 10 is -22. So those two numbers are different, D and E. So remember when you learn piecewise functions, like this is why we care. So at 1, so we have like this, and then they like overlapped, and then you had a line, and then you have a jump. I don't know, this is clearly not correct, but so a lot of kids would ask, okay, but they fill in the hole, and they're the same point. We want that to happen, right? If that happens, it's nice. Our limit exists. This is a terrible picture. I'm sorry, guys. All right, pause the video. Try this one on your own. All right, 1 from the left. That's ln of 1, which is 0. 1 from the right is 0. 1 minus 1, and so the limit exists, and it's 0. 4 from the left is 16 minus 1, which is 15. 1 from the right would be 9. So D and E does not exist. All right, so now these are actually in your textbook. These are practice AP questions. So take a look at these, pause the video and try them on your own. Which statement best describes the limit as x approaches 3? The limit is 1, the limit is 3, the limit is 4, or the limit does not exist. So the limit is 1, because, okay, that was awkward. The graph is approaching 1 from both sides, even though the function value doesn't exist. The limit as x approaches 0 if the function cosine is equal to the number 1 is written symbolically as the limit as x approaches the number 1. So C and A, you have cosine x approaches. No, we don't do that. Same, it's always either for C or D, x approaches x arrow a number, x arrow a number. This one says x approaches 0, so it's this one. All right, use the graph to determine which of the statements is true. The limit as x approaches -1 from the right does not exist. That is false. Pretty much left and right limits usually exist. It's very rare that they don't. That point is where it would exist. So that's true. Or that's not true. It says which is. Use the graph to determine which is true. That's false. It does exist. The limit as x approaches 1 from the left equals the function value. Oh, that's true. Because the limit as x approaches 1 from the left is here, that's also equal to what f of 1 is. Let's just check the others. The limit as x approaches 1 exists. That is false. Remember, there's a gap. You're not allowed to it's not going to work if you have a gap. The limit as x approaches 4 equals f of 4. That's not true. The limit is up here, but the function value is here. So that's not going to work. All right, that is lesson number 2. Write down your homework. If you have any questions, email me. Bye, guys.